heard on the internet.
Hello, everybody. It is 10:35 p.m. Central Time on the 9th of December 2020. It's Wednesday night here in the United States. Impromptu late night update. I'm going to try and record this. We'll see if we can get it out over on YouTube, but let me get a display capture turned on really quick. And this is going to be like a turbo update. We're just going to run down the areas that were hit since my last update, and we'll focus in on the United States mainly. But first of all, over here in the West Pacific, multiple 4s and 5s in the past few days, topping out 5.3 in the West Pacific. But since then, going out over into Russia, Lake Baikal, right on the edge of our arrow, a 5.5 earthquake, a pretty noticeable sized event there. On top of the 5.1, oh, hold on. Alright, come on. Out you go. Alright. That's how this update's gonna go? Okay. Alright. I need to lighten up a little bit. I need to have a little bit more fun with this. That was Miss Wednesday. She's 20 years old, going on 21. So, yeah, got her. She's a Y2 kitty. Y2K cat. Yes. Okay, so going across Russia, going across over Myanmar, we have our 5s. Then we have a big open silent zone with not much seismic activity. We had 4s a day ago across over in Nepal and going over to the west. But since then, not much. It's gone completely quiet. 4s down in South Iran, 3s going across over into South Mediterranean, 2s going out to Western Europe. But look at this. The cumulative total of everything that came out of Europe, which was in the upper 4 range, struck out here in between our two X's. That's right at the pinnacle tip. In between the two X's, that's from a day ago. I'd like to draw your attention to what happened all the way across over here in Central and South America. For instance, South America, on the coast of Chile going into Argentina, we had our 5s a day ago. Now a new 5 struck down at our X marks the spot, as well as a 4.9 on the way over north of Antarctica, but X marks the spot, 5.1. It's about the same size as what came in, which was a series of 4s and 5s, or a 4s and a 5. Additionally, up to the north, a series of 4s and 5s have struck across the coast of Central America. Now, all of a sudden, swarming over to the east, over in the eastern Caribbean, and we have a few deeper earthquakes along with that. They're not terribly deep, but it's all 2s and 3s, but 2s and 3s swarming. That's a step up from where we were, and I'm expecting that to go up majorly over in the eastern Caribbean into the upper 5 range in the next few days. Now look at this. We need to get into the United States because, man, look at these stacks of earthquakes. This is about, here, let's get 48 hours on here. Okay. See how it's getting choppy, kind of hard? Okay, we have 3,121 total earthquakes on the feed right now. And we were at like 2,000 last week for the week. 2,400, 2,500, maybe 2,500. So we're higher than we were last week in the number of earthquakes. But dude, in the last day, sorry to be so casual on that, but seriously, in the last day, the number of earthquakes has just gone through the roof. Number of small earthquakes, that is. 4s and 5s, yes, too, that's also gone up, but all of these smaller earthquakes, I mean, it is just packing the feed. We're also having some rare earthquake locations be hit. So, for instance, over in western Colorado, look at the 3.0 range activity. Look at this. Look how it's spread across the plate. Western Colorado at a place called Bedrock, right next to a drill point. Oil and gas drill point. I think it's fracking there. 3.3 over at the Oklahoma-Kansas border at another fracking operation. And a 3.2 all the way up here at South Dakota, right near the North Dakota border. And I couldn't find anything there when I went to go look it up earlier. But look how all 3 earthquakes are symmetrically spaced across the center portion of the craton from the edge to the center. Do you see that? Compare the craton diagram to the 3 different earthquakes. Now, coincidentally enough, we have a 3.6 down in Southern California from a day ago, as well as a 3.5 to 3.6 right up there at the California-Nevada border. So that's a lot of 3.6 activity, wouldn't you say? 3.6, 3.6, 3.6 in their own triangle, if you will. Not if you will, they really are in their own triangulated pattern there where each ring bisects the other. And then we go over here and we take a step slightly down to 3.3, 3.2. Now let's look at the other activity. Down to 3.0, we add in just one earthquake technically from today or last night over in Kansas, which I already talked about last night. And then boom, Maine, New Brunswick border was hit. And man, I don't know how much more specific I could get with naming areas. We talked about Vermont, New Hampshire, Quebec, Maine, New Brunswick. I brought up the volcano at the Maine-New Brunswick border. This was 6 days ago in my update when I issued the warning for 3.0 range activity to come rolling in up here at the Maine-New Brunswick border, secondarily down at Vermont, New Hampshire. Let me show you what's there. So these are the coordinates for the 3.0 earthquake. And I'll show you the spot I was talking about 6 days ago. In my YouTube video, you can go find it from 6 days ago. So on December 3rd is when I was talking about this spot right here, which if we zoom in really close, we get a place mark from Google for Mount Pleasant Caldera, a large eroded late Devonian volcanic caldera complex here. That's the oval shape, actually, of it, but that mountain in the center is the place mark for it. Over here on the western side, we have Spednick Lake. But anyway, that's the spot I was talking about. Then I talked about the supervolcanoes located down here on the coast of Maine. So there we are. We have a 3.0 range earthquake over here on the east coast, on the east edge of the Craton, right next to the warned area on day 6 of the warning, 7-day warning. So overall, it's a spread of 3s going all the way across the plate. Taking the smaller earthquakes into account, all that does is fill in the areas, middle points between the 3s. We even went down into Mississippi, down on the edge of the Craton, down to the south. Add in Georgia, bending on the edge of the Craton one more time. So overall, we've got a lot going on, seismically speaking. Now, I want you to look at the smaller earthquakes. Look at this. Wait a second. Let's just wait for it to refresh here. Hold on. Okay, now I'm going to zoom in and it looks like a jumbled mess because it is. This is, again, 48 hours worth of earthquakes here. And let me just turn down the rings. Look at the path of small earthquakes that has taken place in the last day, coming out of Canada, going down across Montana, down into Yellowstone, where, man, we are swarming out. It is just stacked up with small earthquakes. A spread of smaller earthquakes going down into Utah, and then it makes like an arrow shape. All the earthquakes make an arrow shape over to the biggest of the bunch, which is the same size that came out of California. 3.6 came out of California. Well, 4 actually. We had 4s over in California and a 3.6. Now we go over here to Colorado, and it's a drill point at Bedrock, Colorado. Let's go show it to you. 0.4 kilometer depth. Okay. Paste in the coordinates. You guys should do this whenever you see a significant size quake. And look at all the red dots, by the way. See all the red dots? Those are all hot spots. Those aren't farmers burning their fields either. We're talking about major flare-up on the hotspot activity along the power lines and pipelines. Now look at the town, Paradox. Here's Bedrock, the closer town, and I've got the nearest drill point marked. Now we have our, look like saline ponds out here. I might be wrong on that, but the fresh water they usually take in and mix with and then inject. Okay, that's where we are. But like I said, all those hotspots, look at this. Look, the whole Midwest today, I mean the entire United States. Here, let me see if I can get these all in one shot. The entire Midwest U.S., from the north all the way down to the south and all the way down to South Florida, all lit up with hotspots today, thousands of them everywhere, just as the sun was facing this side of the earth, as the solar storm started to arrive. Now the solar storm's in full effect, or at least supposed to be, at least going into the 10th, where Aurora Borealis, northern lights, could be visible as far south as Oregon, going over to Ohio, and over to Pennsylvania. Iowa, Pennsylvania, right across here. That's coming down low. They say south of the 50th latitude mark. So all these little red dots showing up on the electrical grid, you can zoom in and find out that most of these are coming in next to electrical lines. And the hot spots are, and on railroads too. So railroads and electrical lines are both showing it. Now, I don't know what's here. I'm just randomly zooming in on these, but I'm thinking I'm going to find a set of high voltage power lines right down at the spot where the hot spots are. Yeah, look at this. It's either a pipeline or high voltage power lines. No, these are the high voltage, big kind, not the kind that go to your house. And how could I have known, right? So let's just zoom in on these and see how close we are. Again, we're so close to these. It cannot be a coincidence. And of course, with the solar going on, that could definitely affect things power-wise. Create some kind of heat or feedback or electrical discharge or arcing or hotspot, but it's spread out somewhat equally. As the sun spread out across the center part of the plate, all of a sudden, all these hotspots suddenly appeared. And it wasn't just there, guys. Let's go over on the West Coast. As the sun went over on the West Coast, we saw a flare-up in hotspots across Colorado, Utah, going over into Oregon, across the coast of Oregon. And they're marked here with the little red dots. So we have an earthquake over in western Colorado, and we have two hotspots that appeared here in western Colorado. Grand Junction, just east of Grand Junction, two hotspots here. Well, look what we're right next to. Do you see all these? Let's go zoom in and see what we have. We have oil and gas pumping operations connected by pipelines on the surface and pipelines that go down into the crust by several kilometers. Now, I would propose to you that those two could become like giant antennae to receive certain quote-unquote frequencies from the sun, VLF. A few kilometers long, antenna in the ground. So that's all going on right now. We have our earthquakes that are pointing like an arrow across Utah, following our arrow that we have here. I don't know if you can see it there, the red arrow. It's, again, this is 48 hours worth of earthquakes. It's not like I'm having to cover this all the time like this, where there's this much activity. Again, when was the last time I was able to show you a great connection of small earthquakes going all the way down the Creighton Edge, terminating at a pumping operation in Colorado? I mean, it rarely ever happens, only when there's solar going on and we're already going through a plate shift of some kind, and we're just tailing off with that episodic tremor slip on the West Coast. So, recapping really quick. Earthquake over in the warned area over in Maine, at the Maine-New Brunswick border on the East Coast. 3.0 was warned for, 3.0 hit, plus another 2.4. Smaller earthquakes going back down across the south, and I didn't even talk about Mississippi and the drill points down there, but on the north side, we're up on the New Madrid seismic zone with the 1.1, just two small earthquakes on the New Madrid. In other words, the East Coast is pretty low, 1, 3, and a few 2s. Once we get back to Oklahoma, the stacks begin, and the whole state of Oklahoma shifting now. Every one of these locations, including the swarm spot where all the stack is, are drill points, oil and gas. Let me show you, in case you don't know. Quinlan, Oklahoma. Okay, copy and paste. This is how you do it. Get the coordinates for the center of the swarm, put it in, go see what's there. A lot of times you'll be shocked to find there's something at the location leading to the cause of the swarm. In this case, look what we're zooming in on. 2 tanks, a pump, a jack, protective berms around the tank, a burn flare-off apparatus, and next to it, more of the same. And there's the shadow of the nearby actual jack. And all of these little square pads in the ground are different drill points that go down into the crust. A few hundred to a few thousand feet, maybe even a few kilometers down and out and away. They can drill at an angle, not just up and down vertically. They can drill horizontally, side by side, out by many miles. And look how many we have there. For every one that I have marked, let me show you what it looks like where I don't have them marked, but they still exist. Do you see all these little square pads going down the roads? So there's a square that marks out the actual land, and then there's the little white square pads that are set along here. Every one of these is a different oil well. Oil and gas, fracking. Let me back it out and show you how many there are. So a whole line of them there, for instance. There's another line of them down here. And we go across whole counties where whole counties are done this way. 500-something thousand different drill points across Oklahoma, and we're over here swarming out, and every one of those spots, we can go across the whole state, and it looks just like that, all the way down to here, to where the blue earthquake I just highlighted is. So back across, we can just go a diagonal line across. I can just randomly zoom in and show it to you. So here's the previous earthquake I just looked up, the swarm. And we're going to go east by southeast, just randomly across the area and show you. So where all the earthquakes are striking across here, I can zoom in. And every one of these is a different oil well. And gas well, fracking and oil. We keep going down to the east-south. Oh, look, we have a hot spot out there. Let's go see. Is there an oil well there? Is there a power line? Oh, look, there's 2 power lines, 2 huge sets of pipelines and power lines. So I think the pipelines, too, at the surface and in the crust, can also accentuate this incoming electrical charge or outgoing electrical charge. But there's a hotspot, right, power line. We have earthquakes going all the way across here. And we go down to the east-southeast part of the state, and that's where we dead end with this 2.4 down at Quinton. So we go from Quinlan to Quinton across the whole state. Got a lot of quints going on there. And there we go. How many more do we need to get to Quint? 6? Oh, that's weird. You know how they are about those 6s. Okay, so here we are. Zooming in on the area, what do we have? We have another tank, pump, jack, and pipeline. There's the shadow of the jack. Right there. Bunch of oil and gas. More oil and gas on both sides. So it's not just one there. There's a whole bunch. There we are. I just proved my case. So each one's a drill point from one side of the state to the other. All the way across. Going back down to Texas, do I even need to show you what's in Texas? I showed it before. Same thing that's in Colorado. Same thing that's in Texas. Same thing in Oklahoma. Same thing in Kansas. Drill points. Now once we get over to the east, we get on the edge of the Craton. We get over to Georgia, and it's not drill points. It's strictly Craton edge moving. Same with up in Maine. There's no drill points there. It's an old volcano, a weak point that Mother Nature made on the edge of the plate. Now let's go back over to the west, because again, I mentioned this in Utah. It's like an arrow across Utah, pointing over to Colorado, which I just showed you, Bedrock, Colorado. All of these other locations, though, going across Utah, I guess I just need to show them to you. We'll go pull the coordinates and start up here at the north side. And we're just going to go back and work our way all the way back to California, eventually. This is going to take a long time, guys. I was just going to do this as an impromptu update, but man, this is going to turn into one of these long-winded updates when I look these all up. And you know what? I'll probably pull one out of every other one so we don't take so long. Here we are on the north side of this valley. Starting on the north side of this valley, more oil and gas. You see where it says oil over here? We can go all the way up to the north side of the valley and back down, and there are drill points. Let me zoom in and show you. So I marked one. Again, jack, tank, pump, pipeline, burn apparatus for safety purposes, and then the little pads that go through the mountains here, every one of them is another drill point. And they're connected by pipeline, so we know that they're doing some kind of oil there. Or gas. It could be gas, but I think oil. Now it goes up through the valley, all the way up here to the north tip, where there's more. And you can just follow it up through the valley. I'm just randomly zooming in to show you. So more and more, and then we go through the mountains themselves. Oh, look, a hot spot there. Okay, hold on. We have a hot spot over here, right on the edge of our pumping operations. I'll show you where we're on the edge of. Let me just zoom in and see if there's any on this side. There might not be. These might all just be little sand dunes and so forth. Okay, now right here on the other side, over here, are all of our drill points. And I mean major. We're talking thousands and thousands. There's a derrick with a new drill point being made right there with the derrick. And look at that. Again, every one of these little square pads is a different drill point. Okay, so we have a hotspot right next to it. Do we have a power line or anything? Looks like there's more up to the north. Let's go see. Do we have any other things nearby that could be leading to that? But we're close enough. Again, when I start getting close within these oil pumping operations, it could be methane coming up out of the ground too, which is something we talked about when these hotspots first started to show up. Let's go up to the north and see what the one is up to the north. 1, 2, 3, 4. They're in like a somewhat equal spacing across this area. What is going on here? Is there anything here going through these areas? Something's going on there. Now, it might take me a little time to investigate, but I'm not seeing anything here nearby of any consequence. So it's not like there's these high voltage power lines don't seem to be turning up everywhere unless I'm just missing where they are. Am I missing where they are? Oh, wait, I am. Right across the valley here. Hold on, let's just make sure before I say that that's what they are. Yes. No? Pipeline. That's a pipeline. There's no poles or anything holding up any kind of electrical lines. So, a hotspot in the middle of nowhere with nothing nearby of any consequence. An old road with no high voltage anywhere around it. Right across Hannah, on the other side of the valley, we have another hotspot. And is there anything there? Not that I can see. Look, this is getting odd. With the solar storm incoming, it makes you wonder what is the ultimate cause of the hotspots. Some are next to power lines and railroad. Other next to volcanoes. Okay. Over in Colorado, we're just north of the fracking operation that I showed you. We're even out here in Nevada with a couple hotspots now, which is very rare. We hardly ever have hotspots out here. One of which is coming in a basin next to an old river. With nothing on this side. Well, what is this? A road? Is that a road? Yeah, a road out in the middle of the desert. But that's still fairly far away. What is this? Railroad track. Okay, we're right next to a railroad track going through the middle of the desert. What about this down to the south? A quarry. A deep earth open pit mine quarry. Right in the middle of it. Things couldn't get any more weird, could they? Well, do we have any more? Hey, look, we have some down in Arizona. Let's go see where they are. Another quarry. So we have a hotspot at another quarry. Okay, hotspots at quarries all of a sudden. Look at the rest of the United States. Even going up to Yellowstone, outside of Yellowstone, over to the east, a ring of them, mimicking the shape here of the mountain range. Let's see, the town of Lucerne. Looks like we have something here. That's a road. We do have farm fields here at this point. This is the first spot that actually has some kind of real farm field there. Oh wait, look what's right here. Obviously, we've got oil and gas there. Okay, so we have oil and gas there. Oh my gosh. Okay, let's go over on the West Coast and just go see what's going on here. Because across Oregon, I mean, we don't have a lot of oil pumping going on in Oregon, I don't think. Over here along the coast of Oregon, for instance. No oil pumping operations over here. Just woods out here in the middle of nowhere. A few mountain roads, it looks like. Mountain roads. Nothing on them. Neatharts Bay is the nearest location ocean-wise. Pleasant Valley. And over here to the east, look, this is where the shifting was taking place. Wasn't it? Isn't this where the shifting is taking place with the slow slip? Here's another hotspot here. And again, just Forest Service roads. No power lines. I've got to go check the tremors now. Okay, this leads us nicely into the tremors. So while we're checking the hotspots and we're seeing like a record number of hotspots show up all at once today while the solar storm is arriving, let's just... Well, actually, before we do that, one more thing I'd like to check. Earthquakes going across the area up in Oregon. Nothing. Now, that's odd. Look at Washington in the past day and a half. Look over to the east in the last day and a half. And look down to the south in the last day and a half. Now look in the middle. They're not reporting earthquakes. And now it glaringly, obviously shows to the whole world. It's troubling for them not to report earthquakes out of Oregon, especially at a time where the rest of the plate is dynamically shifting. That being said, with dynamic shifting, let's go up and look at the tremor map. 8. Let's go to yesterday. 6. Let's go to the day before. 72. So it goes from 70 down to what I said was the threshold for me to consider it to be over. What are the chances of that? I want you to think about that. I said it would have to get down to 6 or 7 for there to be a stop, what I would consider to be a stop in the slow slip. And then it goes down to 6 and 8. It's weird. That's weird. It's like playing the lottery, but with a number that's infinite. So, I'm going to say it. It's weird, but we're going to take it at face value for what it is, that the slow slip has finally slowed down. That the ETS, at least for the time being, 2 days in a row, has gone down to next to nothing. And while the ETS, the episodic tremor slip across Oregon, Washington, Northern California, and Vancouver, was going for almost 2 months, look what's happened as it's quote-unquote stopped. All around it, the whole area that shifted, now the area around it starts to release the stored up energy. And the whole edge, deformed edge of the craton, has been displaced. I'm going to turn off the magnitude so you can see this overall. Look at it this way. This is the last 2 days worth of earthquakes. Here's the last week. Let me get this as it refreshes. Sorry, 3,000 earthquakes are refreshing right now. Okay, wait, click, click, click. There we go. So here's the last week, but I would definitely say it in the last day. It's definitely increased out on the West Coast. But do you see how it makes a ring? Now compare that ring that goes down through Montana, down through Utah, down through Wyoming, to the edge of the craton. The deformed edge that goes into the formed edge, into Colorado and New Mexico and Texas. And it carries on over to the East Coast perfectly. So in the last 7 days, look over all the way across, even New Jersey got hit. Right in the middle between Georgia and Maine, along the edge of the craton. Even the middle of the plate is moving up at South Dakota, which really tells us something's going on with the plate shifting, which we already know because the plate was shifting previously with the episodic tremor slip, with the tremors. And then the solar flare now, or the solar CME took place, small flare, but big CME coming towards Earth. And it's arriving now. And in the last day, things have gone through the roof across the West Coast. So like I said, Yellowstone is swarming, and it really is. That's a noteworthy increase in the number of small earthquakes at Yellowstone. Now I have to stress with Yellowstone, there's normally hundreds of tremors per day, if not thousands. Tremors, though, are not earthquakes. Tremors are vibrations as the plate, or magma chamber in this case, shifts a little. But in these are earthquakes. These are actual fractures that are taking place. And the fractures that are taking place are going all along the edge of the craton. You can see them going up into Montana and down into Utah. Back behind it, in central Idaho, right above the deepest part of the center of the magma chamber for Yellowstone, which goes up to the surface at Wyoming where the swarm is, there's another little swarm, but actually the swarm isn't that little. It's going up to 2.8. While all these are zeros and ones, this is a 2.8, 2.9, 2s. These are bigger earthquakes above the deepest part of the magma chamber. But these earthquakes, make no mistake about it, are above the magma chamber for Yellowstone, which is nestled at an angle down below Idaho. 11 Grand Canyons in size. So when it starts to move, that's when we pay attention. And it's moving. There's actual breakage happening up at the surface a little bit. Highest it's going is 2.6. 2.6, a bunch of zeros, ones, and a 2. Whereas over to the west, a bunch of 2s going up to near 3. Over to the west, pretty much all of central and western Washington moved in the last day, but I have to go look up the quakes to make sure that they're not explosions or other reports of other things. Just really quick, I just got to go turbo mode this. For instance, an explosion out there in Washington. Okay, we're going to leave that as it is. Let's go look up at the 1.4. Now wait, this one's not an explosion. So we have an explosion and not explosion. Two of them side by side, pretty much. Let's just go see what's there at the not explosion site. Royal City, Washington. I have a sneaking suspicion that I already know what's here nearby. Ah, yes. Here's Royal City. Here's a mountain ridge or range, and on the other side is the Hanford Nuclear Waste Storage Facility and the LIGO Gravity Wave Sensing Station with its long lasers. And the gravity wave sensing and the nuclear reactors that used to be here that were all dismantled, and they left the crypts or the caskets still there maybe, but all the material was moved to store at the center. So we get a bunch of earthquakes that break out around this thing. And hotspots and fires. Enough so that we've focused on this area so many times because of the previous seismic activity that strikes around the area. And a one-time, just as one example, series of earthquakes broke out around this thing, and within a few days after that, a shift took place across here that cracked open the surface and exposed an underground rail line or tunnel that had a bunch of old train cars in them, and the tunnel roof collapsed in. And in each car, not covered up, were uranium millings, powderized uranium that blew out in the wind when the tunnel collapsed. But that was just a day or two after the earthquakes broke out around this thing. Another time, earthquakes broke out around this thing, and then a bunch of fires broke out around this thing. All the way around it, like a ring. First the earthquakes, then the fires. It happened again and again. It happened like 4 times in the last 5 years. Fires broke out around, in a ring, around this, as earthquake struck just a few days before. Now we have a new earthquake there, and a bunch of hotspots across Oregon. Okay. So, one's an explosion, huh? I'm curious. I've got to go look it up. I've got to go look up where the explosion is happening. Because who would be blowing something up out there right now? Let's go see. Could be at a quarry. Never say never. Let's go see. Could be right at a quarry, and that'll answer all our questions. Well, it's like a mile away. I guess that's close enough. Okay, we're next to a quarry. We're not exactly at one. We're a mile away, which, again, triangulated coordinates can be off by a few guys. So we'll cut them some slack. I'm encouraged to see that it's actually at a quarry. There's been many times where we get in and there's no quarry there at all. It's on a mountain ridge in the middle of nowhere. And it's not a dynamite blast. It's, okay, anyway. So one is an explosion, one's an earthquake. Got to look them up. Now down along the coast over here, going over into Oregon, let's just quickly pull that from yesterday. Earthquake. We already looked it up yesterday. Right along the coast. It's marked in pink. Technically, I could get that out of there. I just was showing you the day-old earthquakes just to make a point about how much is hit. But here we go. Here's what's hit since. So it's not that much of a change. We go about 20 miles over to the east, and we're back in southwest Washington. These are not explosions. Down here to the south at the border. Up to the north, 0.1, not an explosion either. We're at Ashford, Washington. We're on the side of Mount Rainier volcano. And that just is something that we normally see. Actually, it's not anything to be alarmed about. It's not going to erupt anytime soon. We're quite literally on the flank of. Here's the crater. Here's the side. And we're down below inside of the volcano. Now that's a change because we were around the outside edge, more on the extreme flanks or perimeter of the volcano. Now we're back up at the crater. But the reason we're below the crater at all is there's a slight amount of pressure coming in from the Juan de Fuca fracture zone, which stopped shifting. So if it stops shifting, that's when I look for it to break and release. Now the solar adding into this, I don't know. That's the wild card. I would think that that's going to cause an increase across the board at every location, and the magnitudes are going to go up at every location, and the number of earthquakes are going to go up at every location as the solar storm arrives and perturbs the magnetosphere, which goes down into all parts of the Earth, which then, of course, there's an earthquake effect. Now look at this ring going around California in the last 48 hours. Even a kid could see it, but let me turn off the magnitude so you can just see the rings themselves. Each ring indicates an earthquake in 48 hours. Or actually, this is 24 hours. Here's 48. I'm telling you guys, look at the increase. We call this a frequency increase. When the number of earthquakes goes up, that's a frequency increase. Think of a snare drum rolling really fast. And just this past week, I mentioned that California was just like a whole half of California was just like a drummer hitting the drum one at a time, that the snare drum had stopped and that the snare drum was going to pick back up. Well, now it's in full roll across all of California, all of Utah, going along the edge of the craton, and we're supposed to think that there's no earthquake activity across Oregon, but if they showed it, you would see what looks pretty much like in Washington going across all of Oregon as well, and it would connect down into California. And you'd see the whole West Coast making a big ring of activity going all the way around the deformed edge of the craton, over to the edge of the craton, and making its way down to Colorado. That's what you would see if they showed you everything. Okay, so a line of quakes in the last 48 hours, starting up here in Northern California, branching off in two directions. Sound familiar? Going across the valley to the north and going in a diagonal line down the California-Nevada border. It speaks for itself. You can see it here. These are all the earthquakes from the USGS. Same with down here along the California coastline is another diagonal line of quakes. But this can all be seen together on one map on the USGS plate boundary map marked with the faults. So the plate boundaries are the red lines, these thick red lines around the whole planet. But the faults for the US are marked in a thinner series of red lines, but make note of which way they overall go down at the California-Nevada border. They too go in pretty much the same direction, northwest to southeast, wouldn't you say? A few variations on that, but overall, starting all the way up here at Lake Tahoe and Pyramid Lake, even going up across Northern California, you just follow them up into Oregon. They're going northwest to southeast. We get down here and we run into the Garlock Fault down in Southern California, but nonetheless, the faults still maintain that trajectory, northwest to southeast, even though the Garlock Fault bisects that. On both sides of the San Andreas, too, they're doing this. And they carry on all the way down to the south. But what you're going to find, and USGS is now starting to map it, look, going down across Arizona, Colorado, look, down through Texas, look, they're starting to map it. They are. You're going to eventually see this shape, the Craton Edge shape, down marked through Texas, and I can even show it to you. Hold on. Kids, are you paying attention? Adults, are you supervising your children? It's 10 p.m. Do you know where they are? Wait, it's 11:13. Never mind. Down here through Texas, look at this. Do you see this U shape? Looks like a river almost, doesn't it? That's a 1,000-foot rise. This goes from 400 feet above sea level up here to 1,500 feet above sea level across here. And it's that way all the way up and back down and around. And you'll notice it makes a U-shaped bend and meets up with the mountains over here at Big Bend Desert, where there's a bunch of volcanoes, by the way. Ancient, but there they are. And we go up here to the north and we follow up into New Mexico, following the mountain ranges where there's more volcanoes. And we carry on further to the north up through Colorado up to Yellowstone, back into the edge of the Craton to the northwest. So in other words, the Craton Edge goes down across through Colorado, down through Texas, makes a U-shaped bend. Why am I taking the time to show that to you? Out here on the west coast, out on the edge of the Craton, the deformed edge, we go to the coastal plain of the accretionary belt. All these faults focus in on where the deformed Craton comes in. Look at that. Look at the deformed Craton, the purple part, out at the California-Nevada border. Guess what's right where the deformed edge of the Craton meets into the green, where the purple meets the green at the California-Nevada border? Long Valley supervolcano is right there. Here it is. Here is Long Valley. So wait a second. Long Valley supervolcano with 1,000 cubic kilometers has formed at the borderline between the purple and the green on the Craton diagram at the California-Nevada border. But the other well-known supervolcano is Yellowstone, and it's up here at the other Craton boundary where the purple meets the rusty brownish color. So both of our supervolcanoes in North America have formed at the seam between the deformed craton and the areas on either side. So the deformed craton is our avenue by which the force flows. And we're not let down. Look at the edge of the craton and deformed craton. One more time, a line of earthquakes in the last 48 hours going down across the craton edge. That's in Montana, Idaho, Wyoming, Colorado, Texas, Oklahoma. And the deformed craton edge is also moving all the way out to the coastal plain. That's along the California coast, of course. But this is so interesting. This shape of earthquakes in the last 48 hours makes a ring around all of California, doesn't it? And you really see there's only two spots where it's coming across the valley. One up here to the north, and the other down here to the south. So we should really focus on the spots where the energy is coming across to go see what's there. So let's do that. Two sets of twos up here in the north part of the valley. One's over in the eastern side of the valley, one's in the central. Now this is the spot where the hot spots have been appearing for the past several days up in northern California. Hot spots have been appearing across the north tip of the valley. As the valley's been shifting and showing tremors, those little red dots on the tremor map here, that a few days ago we were in California. Let's go back to like the 3rd. See, we're in northern California with all the little red dots where the plate is shifting. Right there in the north tip of the valley. That's where we just jumped across with our new earthquake, right? It's got to be related. The plate shifted right there. So anyway, let's go get the coordinates on this. 2.0 at Manton, California, and paste them in. Hey, we still have a hotspot marked there from today. We'll go look at that. We're at Tuscan Buttes, Black Butte Cone South, and the Inskip Volcanic Buttes. These are covered in trees. This is lava flow, covered in trees. Nitrogen rich, capable of trapping moisture in the arid environment around here in Northern California. And look what goes right across Inskip. Gee, I wonder why there'd be a bunch of earthquakes that strike on this old volcano. Right next to it. Maybe it could have something to do with the electrical discharge, the sun and the crust in the earth holding electrical power. Could also have something to do with all the Mother Nature punch points here from Tuscan Buttes volcano, both of them, which themselves have two giant microwave towers, 1,000 foot, on top of each hill. And this one's got all the dishes on it. The other one's the 1,000 foot. Pretty interesting. They have that on top of each volcano, isn't it? So we have high voltage power lines, we've got volcanoes, and we've got, well, power, electrical power going through the area, volcanism, and solar. Put it all together. Down to the south, let's go down to the south tip of the valley, where we're jumping across here. We'll go look both of these earthquakes up. So we're jumping off the San Andreas. Almost called it something else. Glad I didn't. Okay, so here we go. Let's go put the coordinates in. We're at Kettleman City. Sound familiar? Kettleman City is the spot where the USGS did extreme studies, long-term studies, well-financed studies, to find out why the area from Kettleman City to Bakersfield, from here down to here, was subsiding, and the whole area is sinking majorly. They try to figure out why. Well, when you zoom in on the areas, what you'll start to find are, around here, for instance, as you zoom in, you're going to see all these little spots in the ground. You zoom in on the spots in the ground, and you'll see this is something that many people might not be aware of. The oil pumping operations that are out here that are absolutely massive. Each one of these is a different jack, pump, tank, pipeline, and it connects down to the south to hundreds more. And once we get down to the south from there, we get into thousands of drill points. Every one of these is a different oil well, by the way. And this is actually low, all of these. This number is low in comparison to what I could show you down to the south. But we jump on to the pumping operations, jumping off of the San Andreas. Now, we started to go around the San Andreas yesterday and down to the south, down next to San Luis Obispo. Now, in the most odd twist of events, when the earthquake struck next to San Luis Obispo, Within a few hours, the mainstream media came out with one of their bogus disinfo stories about those mystery monoliths that are appearing everywhere. And guess where it appeared? Right next to where the earthquake was at Arroyo Grande. How about that? So I don't know what to make about those earthquakes, but maybe somebody went out there and placed the monolith after the earthquake struck. That's what I'd think. Now let's talk about a hoax and a half with that. So where are we here? Well, look what we have. We're right next to a lake called Lake Success. And we have a dam here, but I don't know if this is used for generating electricity. Let's just look in and see. Oh, wow. Okay, well, yeah. We've got, look at these power lines coming off this thing. Let's see where they're coming from. Yeah, look at these towers. Huge towers. Well, isn't that special? Damn hippies. Damn hippies out at Lake Success. Okay, we got huge electrical generation going on at that location. So, again, hydroelectric dams are hard to come by. We don't exactly have a lot of them. So to get an earthquake right next to it, it pretty much seals the deal for me. So we're going from a drill point over to a power point. We jump off the San Andreas, going over to drill point, power point. Up to the north, we're right next to power point. I didn't look this one up over to the east, the little swarm. Should I pull the coordinates over next to Lake Almanor, Hamilton Branch? Let's do it. I mean, if I looked up the two down to the south, I guess I need to look up the two to the north, just to be consistent. I said this is going to be a turbo update. I guess it is, technically. It's like watching a turtle crawl, though, isn't it, guys? Here we are. Hey, we always win in the end, don't we? So, we're at the edge of Chester, Lake Almanor, and we're on the flanks of Mount Lassen. I mean, we're right next to it. The stratovolcano. Now, I just want to see, is there anything else here nearby? There might not be anything, but I have to look and see, are there any high-voltage power lines that are running through the area right next to the lake or something? Those are all roads. I would think that they were doing some kind of geothermal up here, that they would take advantage of that for their power, but I wouldn't. I really don't know. Okay, not much of any interest, except for the huge volcano right next to it. So that is something of interest. Now the rest of these earthquakes, we go across, for instance, Pyramid Lake. Pyramid Lake, Fumarole Field, Geyser Field, at the Needles. We go over here, we go to Soda Lakes. That's a Smithsonian-marked volcano. We go just south of Lake Tahoe, or south of Reno, and we're just south of Steamboat Springs volcano. These are all well-known, well-marked volcanoes, so I don't even really need to show you. The other big stack over here along the coast is at another well-known volcano, Clear Lake Volcano, Geysers, Geyserville, California. And these are all locations that I show on a regular basis. I don't know why this one's not loading. There we go. Geysers, California. And don't be alarmed when you see all these volcanoes getting hit. They're weak points in the crust. Mother Nature is bombarding Earth right now. The magnetosphere has to be going into overdrive at this point. If not now, soon. And that has an earthquake effect. Again, at the weak points. Whether they're Mother Nature made at a volcano, or whether humans drilled in, like over in Colorado at bedrock, or in Oklahoma, these perforation points in the crust vibrate. And VLF is many kilometers long, if not thousands of kilometers long. But certainly enough that I think that these long power lines, long railroad lines, long pipelines, long oil drill points, and long Mother Nature punch points like volcanoes in the crust, that these areas are earthquake prone when bombarded in the right way with the right amount of power. And the earthquake increase definitely goes with that. Now over to the east, the number of earthquakes in the last 48 hours, just like I said in each other location, has increased. We've seen the snare drum start to go up in the number of earthquakes at Monte Cristo Hills Volcanic Center, at Mono Lake, California, which apparently I've been saying wrong the whole time. M-O-N-O is Mono. Okay, Californians, we'll do it that way. Mono Lake, California. Okay, sorry. It's hard for me to take the criticism seriously. Okay, so down here across the California-Nevada border at Long Valley caldera. That is Long Valley. It's not Long, Long, spelled the wrong way or something. So we have a spread of quakes going from volcano to volcano to volcano, connecting from the supervolcano over into Monte Cristo. And that's where the stack of earthquakes is there, right along the California-Nevada border. And the California-Nevada border has the purple line that's really the Craton Edge. So along the deformed Craton Edge, there are stresses, which are spreading out across it, and it reaches to the perforation points, whether they're drill points or oil, gas, geothermal, or Mother Nature punch points, volcanoes, fumaroles, geyser fields. They all tend to get hit. And now the power lines are like the wild card thrown in, where humans are maybe precipitating that electric charge down into the crust or pulling it up out of the crust. Either it's shooting it down into the crust or it's pulling it up out of the crust. And we're getting earthquakes by power lines. That's what's going on. So this line of earthquakes down here to the south begins at a power station and ends at a radar field and / government test facility / fault zone / volcano down to the south. So which do you want to go with? The power station and volcano to the north, or the government facility and volcano to the south? That's where the line starts and finishes here across Owens Valley from China Lake Test Facility, where our big earthquake struck last year, by the way. So pretty much starting right about here on the north side of Kozo Volcanic Field, going down through Kozo Volcanic Field, where all of our electrical generating stations exist, the geothermal, drill points too down into this volcano, line of quakes on the east side of Volcano Peak and all its lava flows, and like I said, it dead ends down into a government facility right down here next to Searles Valley. And you go zoom in on these areas and you'll start to find all kinds of interesting things. Bunkers, and more bunkers, and more bunkers. Underground bunkers, deep underground military bases. What do you know what they call those, right? DUMBs, DUMBs. Okay, well, I don't know how deep they go, but there certainly are a lot of them. Now let's go over here to the California-Nevada border again, to a place called Furnace Creek. In my Turbo Turtle update. So this is like watching a turtle race. We're going fast, I promise you. We're at the Ryan Craters here. Now somebody told me that this was not geothermal, and I looked up information previously that showed that it was. Other people told me that this was scrape points for mining exploration. They're doing major mining here, but from what I found was geothermal. I don't know what to make of it, guys. On the side, we do have mines over here, so maybe that's what the people were talking about over here on this side, where the mines, but I'm talking about over here on the edge of the craters. On the edge of the Ryan craters, there's a bunch of old pads that I am fairly certain that this is geothermal that dried up, or they were going to do it and it didn't fully develop or get the financing, whatever. That's what I heard. It was from a local who also contacted me back in 2011. Anyway, we're right next to it. Across the border, we're at Crater Flats, but we're on the edge of the Ryan craters. That's where this earthquake is. Let's go up to the north. A 2.3. Beatty, Nevada? What's out in Beatty, Nevada? Let's go look. I already know, but new people get their minds blown every time we go in here. Do you see all these little pads on the ground? I've been talking about the little pads on the ground all night long, but these are not oil. These are nuclear test sites. Let me turn on the info on these and see if we can find one. Here, U.S. Nuke Operation Goldstone. December 28th, 1985, 150 kilotons. What's this one? U.S. Nuke Operation Grenadier. Salute. June 12th, 1985, another 150 kilotons. What's this one? Tanabo, 150 kilotons. Each one of these, 150. Pretty big. We also let the French and the British come in here and do some tests. I don't know which one of them are going to show up here, but yeah, here we go. UK. Grenadier Egmont, I say, old boy. December 9th, 1984, just a mere 103 kilotons here. Cheerio! Flying back to Britain. Can't do the test there. Okay, that's where the 2.3 is. Oh, man. Okay, put on your tinfoil derbies, guys. I'm wearing my tinfoil Dora, and we can all conspiracize together. Let's go over to Sandy Valley, Nevada. Yeah, Brits wear tinfoil derbies. Americans wear tinfoil Doras and tinfoil hats. I suppose you might be able to get away with wearing a tinfoil Dora. Or, wait. Never mind. That's a joke you might not get. Okay, Enterprise, Nevada. We're on the south side by Sandy Valley. And over here, now, this goes into an old volcanic field that used to exist down here. I wouldn't even call it volcanic at this point, though. Let's see. Do we have anything else nearby? Looks like something is going through the mountains, but it's just a road, maybe? A road with a power line along it. Look at that old mountain road. I wonder where it goes. Why would you have a power line along this old road? Look, it still goes along. What the heck? High voltage. Okay, well, wow, that turned into high voltage. Where? Where did that turn into high voltage? All the way back here? Sure did. Somewhere down in here we go up into a high voltage power line, or maybe it's just not marked, but now I can see it. I mean, I can see the lines on here, and I can see the mast poles, but I don't know how I missed that. Okay, well, we're on the edge of a set of high voltage power lines, apparently. That's just kind of hard to see. That imagery there is too grainy to see it. There's nothing showing down here to the south. But we're close. Definitely close. I mean, there's nothing else there. Not even a marked fault. Okay, let's carry on down to the south. So we already talked about the earthquakes coming down the San Andreas, going over into the valley. And we have a ring of quakes pretty much across all of California. It's all lit up with a lot of activity, and it's going to be increasing from here. We're not going to die out anytime soon. The next several days should be more of this, an increase going across California in magnitudes and in number of earthquakes. So we should see at least several 4s off of this. Several, I mean like 2 or 3. We should see at least 2 or 3 different 4.0 plus earthquakes popping off between our current sets of quakes. But to find the current set between the current sets, there's just, man, it would take me a couple hours to sit down in here and figure out the fulcrum points between all of these. I'll tell you right now, though, I would look on the north side and on the south side. That if this is all moving from here all the way down, that the south side is definitely going to be feeling the full force of this. Imagine it this way. The cumulative total of all these earthquakes is going to add up. And it's going to strike between our current sets of earthquakes. But with so many sets, I would just look to the middle of it all. So the middle of it all brings us right into the middle of the San Andreas Fault. The creeping section, which just got hit with a small earthquake right now, but creeping section might get hit on that in the next day. But over the next several days, we're going to have to just do this on a play-by-play basis. Think of it like this. A huge flood is incoming right now, and I don't know how high the levels are going to go. I know that the levels are going to definitely increase, double and triple from where we are now. So we're going to go from 2s and 3s up to 4s and 5s most likely. And I hope that that's where we stay. But right now we're at 2s and 3s. The whole plate is shifting all the way over to Maine, down through Texas, and even a kid could see this, that this line of quakes going across here looks like a snake almost. One more time, let's show you without the magnitudes turned on, that this line of quakes, making this pattern down here, down to Colorado, matches the outside edge of the craton. And then add in Texas, Oklahoma, and Maine, or go back for the start of the week and compare. Adding in New Jersey over on the East Coast. So it's a perfect match for the craton. The whole craton is being displaced right now, and it's on a 3.0 basis, and this is just the start of where we are. This is the arrival of the solar storm today, and that means over the next several days, it usually takes at least a day or two for there to be a real noteworthy magnitude increase after the solar storm arrival. So it gets captured by the North Pole and South Pole. The aurora borealis forms. That's the huge electric up in the ionosphere. That electric goes down to the crust, basically. So that northern light event that you have been hearing about for the last few days, that's getting ready to take place tonight, supposedly, as far south as Oregon, Iowa, and Pennsylvania, that has an electrical discharge down into the crust. It doesn't just glow in the sky and just magically go away. It has an electrical discharge that goes down into the crust, which then goes down to the core of the Earth, which then excites the whole planet. And that gets me back to where I started the update, which I said was going to be in a turbo mode, which is around the West Pacific. Our activity is going to go hammering through the roof. We're up at 5.5 already, and the storm hasn't even really begun, seismically speaking, yet. Now solar-wise, the storm is upon us. 9th into the 10th, they said strong. Okay, so when I see a big stack of earthquakes, look at it like this. It's slowing down Earthquake 3D at this point. The number of earthquakes that are popping on here. I haven't even talked about Hawaii, but Hawaii and Alaska, you're also starting to move a lot in the last day. Look at all the 4s all of a sudden up in the Aleutian Islands. A bunch of 3s, 2s, 1s, and swarms of 0s just popping off everywhere. It's like everywhere is vibrating suddenly. And that's not an exaggeration to really put it that way, that the whole planet technically is vibrating everywhere. As VLF, thousands of mile-long waves, bombard Earth with charged particles and shortwave radio waves. But at this point, you know what? Maybe we could go look it up and go see what the magnetosphere is doing now that I've got it saved. Couldn't find it the other day when we went to go look it up. It was like hidden. But anyway, let's just look. This is the most current. Oh, wow. Whoa. Hey now, everybody. Pay attention to what's on the screen. First of all, let me take you back to yesterday and show you the difference. Look where the orange line is. These are diameters of the Earth. And here are the satellites. Okay, and they've clustered them in a group, I think, for protective purposes. But this is the magnetopause, which is the area between the magnetosphere where there's the excitement that comes down, and we don't want to see this line come into Earth very close. And it's bouncing around, and think of this like a giant bass drum. So this is connected to the magnetic fields of the Earth, and think of this like a perimeter or a buffer zone, if you will, as the Earth is moving through space. That's another way to think of this. Earth, we're looking down on from the North Pole. The satellites are going around Earth. These are, again, all the satellites that they want to keep track of. So GOES and Himawari. And Earth is moving forward through space-time. So think of this like a boat. Oh, that's a good analogy, too. A boat, where this is the boat. And this is the pinnacle of the boat out here in the front of the planet. And the water is breaking around the planet as the planet is moving through this body of water. Okay, or the boat is moving through the body of water. Well, okay, so keep that in mind. Now we're going to hit play. But this is three-dimensional now. This is like a ball around Earth going around in front of it. Or a comet. Think about the corona on a comet. So it's bouncing around yesterday. This is the arrival of the solar storm. Look at the proton density in the solar wind. The proton density starts to go up as charged particles start to arrive. So it's bouncing around at 7 and 8, 7 and 8, going throughout the day, pretty much steady. Now let's bring it forward to the 10th. Watch this. This is bringing us up to most current. There we go. Boom. Boom, it has arrived. 20 and 30 and 40. Did it spike up to 40 or it was just 20? Hold on. See how it folds the edges in? 20. It peaks out at 20 protons and 500 kilometers squared per second. 516 kilometers squared per second. Square kilometers per second, right? It's not just per second, it's kilometers squared per second. Anyway. Oh, because we're talking 3 dimensions, right? Okay, anyway, looking at it one more time, it folds in, the edges fold in, the diameter of the Earth is shrunk into, it looks like at one point here, hold on. Let me see if I can get it in there at the point where it comes in the closest to see how close it comes into the satellites, because, man, it looked like it came in real close. And we don't normally see it come in that tight unless it's a huge blast compressing the magnetosphere in. So think about how much force it would take to push in the Earth's magnetic field. There we go. There's where it starts coming in. Look at that. Up at 19 and 20 protons. And come forward. That was really close right there. Look at that. Okay, let's just go on, go forward, because it's getting buffeted pretty hard. Starts to push back. Oh, right there, it gets hit again with 20 protons per centimeter. That was a hard blast too. It's getting buffeted right now. Okay. That's pretty intense so far. If that's all we see, that'll be good. But I'll tell you what, that's enough right there to have a seismic increase in the next few days. And the solar wind definitely spiked up by 200 or more kilometers per second. Now, the solar wind speed is not squared. Okay, guys, sorry. It's not three-dimensionally measured. I don't know. I don't cover the sun. I'm doing my best, man. Come on now. Okay, so let's go over and check this out one more time. Hit play on it. Watch it get compressed in. There it goes. It hammers in real close to the satellites, and we don't normally see that. So, one more time. That means seismic increase coming off this in the next few days. On top of what's already going on, which is, to me, again, these stacks of earthquakes kind of tell the tale of a big increase in the number of earthquakes. But I would think the power behind it is also going to be going up with that compression the way it is. But again, it takes a day or two for the conversion to come out of the North and South Pole, the Northern Lights and Southern Lights, to convert from that air glow into electric, go down into the crust, go from the crust down to the core, then the big deep earthquakes start, then we get huge earthquake activity. And it all takes just a few days. The check's in the mail, it's arrived, you just saw it. That was all the real-time data that fed in from the last day and a half up to current. So that was the magnetosphere. Not a simulation. That's what actually was reported as hitting. So looking at Hawaii, you notice anything? Remember those three areas that I talked about in a triangle formation around Hawaii? Now they're distinct. They're standing out. One more time, even a kid could see this. On the north side of Mauna Loa, on the south side of Mauna Loa, or on the southwest side of Kilauea, and right next to Kilauea itself at the Middle East Rift Zone. So like a triangle shape. And this whole area here is recharging. Mauna Loa and Kilauea, but mainly Mauna Loa. I think Kilauea is being displaced by Mauna Loa as it's recharging. So it's recharging because the rest of the plate is moving. And the rest of the plate is moving because of our deep earthquakes. And our deep earthquakes are happening because of a disturbance down below the plates. And the disturbance down below the plates are happening because of the core of the Earth. And the core of the Earth is being disturbed by the solar events. So when a solar event perturbs the core of the Earth, it then perturbs the area up above it, which then causes earthquakes to spread out and away, and we get big, deep earthquakes within a few days of the solar event. And that takes me back to where I started my turbo update, where earthquakes are in more of a turbo mode than I am. And that's saying something. When a geologic process is going faster than I can speak, that's when we know we're going through it. This is what we would call go time, which is a time for you to develop an emergency kit, an earthquake plan, and to watch as this activity increases in magnitude and in number of earthquakes. And to go up from here already, think about it this way. We're dealing with 3,100 earthquakes right now for the last few days, for the last 6 to 7 days. If we add another 1,000 on, that's going to slow down Earthquake 3D to the point where I'm not going to be able to use it very well. That it'll just be too choppy to hold all the earthquakes at once, and I'll have to minus some out. So right now I'm going to minus a few out just to keep it from getting choppy, which I'll put it at a 1.5 and greater threshold that you'll see here on the screen. If I take it down to the full 0 threshold, it's just going to be chippity chop chop as we wait for new earthquakes to come in. What's that? I mean, I can leave it if you guys don't mind. If you guys don't mind the choppy nature of that, I can leave it on. That's fine. If you don't mind it. Okay. Yeah, that's fine. That's fine. I'll leave it on. Okay, well, yeah, you'll see. I mean, you'll still hear the ding of the bell. You always hear the ding of the bell, whether or not it's a 0, 1, or 2. But to see it, again, it's rendering all those at once, those stacks of earthquakes all on top of each other. So that's just, again, no matter what video card I have, that's the program here. It's just that ancient. Needs to get in the 21st century, but we'll see. Okay, guys, word up, much love. People asking me, do they need to worry about the electrical lines melting down? I wouldn't worry about anything like that. It's not a Carrington-type event. So it's a large coronal mass ejection, which then buffets the Earth, creating northern lights and earthquake activity, basically. Volcanic activity can increase, too, by the way. I didn't even really talk about that. So we'll have to get another update out. This was just intended to be a brief update, but it's turned into an hour-long update again. It's unavoidable, no matter how hard I try. One more time from everybody. Hey, we got somebody from Vermont. Vermont! Okay, guys, word up. Much love over on the East Coast. You got an earthquake over right on your... Hey, man, the people who are even more northern than you got it. Maine. Up in Maine. Hey, we're up in Maine. That's my Maine impersonation. All right, guys. At least it didn't hit in Quebec. You can hold on to your Molsons for another day. I'll be back if anything else goes down. I'm being a little jovial, but I would like to remind everybody, don't be scared. You need to be prepared. It's the best you can do. People ask me if they should move away from California. No, I got family out in California. You should have an earthquake plan. That's what you should do. You don't need to move away from it. You run away from one problem, you're just going to run into another. Take it from me, a lesson in life. You try to run away from one problem, earthquakes. You're going to move to, like, the Midwest. Okay, I'm going to get up in the mountains. Okay, well, now you got snow and sleet and all the hail coming out of the mountains. You live in Colorado. You get 3 feet of hail. You're like, they never told me about this before I moved here. Or you move here to the Midwest and you get severe weather, right? You leave one problem, you go to another. You move down to Florida, all of a sudden you got hurricanes. And you go up to the East Coast and you get nor'easters. It's just, stick with whatever problem God gave you to begin with. Endure, have a plan for where you live, and don't leave it unless you have to for some other reason. And on that note, much love. And I'll be back if anything else goes down. I think I am going to upload this to YouTube. That would be pretty unique. Little unique update late night over on the tubes for somebody to watch overnight somewhere. And I'll be back on tomorrow morning or tomorrow afternoon. Most likely I'll be on a lot over the next few days, so I should probably get my rest now. This is the calm before the storm. And it's not that calm, is it? So if this is the calm before the storm, man, what's the storm going to look like? I hope I'm wrong. I hope nothing happens. But the chance of going from this down to nothing? I mean, it could die out for some reason, some weird thing that we haven't taken into account, but I'm all for hoping for the best and planning for the worst. So I would think in the next several days, like the next 2 to 3 days, we're going to be dealing with major earthquake activity over in the West Pacific, like probably one of the largest of the year, which is so weird too because we're in December again. How many times, I said this in a post, how many times are we going to be in December with potentially the largest earthquake of the year? Right around the time of that winter solstice. It's getting weird. It's getting weird. Enough to where I'm starting to wonder if there's a correlation more than just superstition. Because up until now, I've been very dismissive of the whole solstice thing. That there's, some tilt of the planet in some way that, at a certain time of year when the planet's tilted a certain way and it just so happens to be December. But it also in the spring, when we're at the spring to summer equinox, we've also seen that. You guys remember July 2 years in a row, we're dealing with the largest earthquakes on the west coast of the United States. We're dealing with the largest earthquakes in the Pacific in July. And we're like, oh, wow, I wonder if it's a summer solstice thing. Tilt of the planet kind of thing. And then here we are, and we get to December. We got the Boxing Day earthquake. We've got the Great New Madrid earthquakes in 1811 and 1812, right after the winter solstice, in the middle of winter in January and February. So we see these things happen. Is it correlated? If it happens again, look, we had an 8.0 earthquake on Christmas Day in Chile 2 years ago in 2018, or was it 2016? Several years ago, it was back-to-back 8.0s on Christmas Day. Then we had the Boxing Day earthquake, of course, that everybody remembers. We have a load of others. Enough to where it's getting weird. Again, if it happens again now, where we're in December, and we get the largest earthquake of the year that just so happens to strike in December, yes, it is just a 1 in 12 chance, right? 12 months in a year. But, or at the most, 1 in 365, right? But multiple years in a row, then our odds start going up big time, right? Because then you start adding in that multiple year factor where it's like, hey, okay, it's been the last several years in a row in December where we're having a big earthquake of the year, biggest of the year, or close to it. But that's enough to pay attention to. So I'm watching close. Now we are on out of here. You guys have a good morning, evening, night, wherever you are. Peace out.